All right, today we're diving into a paper from DeepSeek AI that is genuinely a game changer. We're talking about a new way to teach machines to process text, not by slogging through it word by word, but by literally seeing it all at once. This is a totally radical approach to one of the biggest problems in AI today.
You know that old saying, a picture is worth 1,000 words? Well, the researchers behind this basically took that idea and flipped it completely on its head. They asked a simple question. What if a picture could literally hold 1,000 words? What if an AI could just look at a single image and instantly absorb a whole page, a whole chapter, or even more? That one question right there is the key.
Okay, so before we get to their absolutely brilliant solution, we really have to understand the problem they're up against. Because it's a fundamental weakness, a real bottleneck for even the most powerful AI models we have out there right now.
So, large language models, LLMs, they're amazing, right? But they have this one major Achilles heel: really long documents. See, they don't read like we do. They chop text up into little bits called tokens. And the more tokens you feed it, the harder it has to work. But here's the kicker. The cost doesn't just go up, it scales quadratically. That means if a document is twice as long, it's actually 4 times the work for the AI. It starts to lose track of what it's read, and the whole thing just becomes super slow and super expensive.
So how in the world do you get around that? Well, the folks at DeepSeek came up with a solution that is so elegant and, honestly, kind of counterintuitive. Instead of trying to make the AI a better reader of long text, they just stopped feeding it text in the first place.
They call this magic trick optical compression, and the idea is so simple it's genius. You take a huge long document, and instead of streaming it to the AI as a bunch of text tokens, you just turn it into an image, a single picture. It's like zipping up a massive folder on your computer into one tiny compact file. The AI can then see the whole thing at once, giving it this incredible bird's-eye view of the entire document, instantly. So let's really spell it out. The old way is like trying to read a novel through a straw, one word, one token at a time. You're bound to get lost. But with optical compression, bam! The AI gets the whole picture, literally, using a tiny fraction of the vision tokens. It's a massive win for efficiency, and because it sees everything at once, it doesn't lose the context. It gets the whole story.
Now, of course, you can't just throw a screenshot of a book at any old AI and expect this to work. Nope. You need a specialized tool that's built for this exact job. And that, my friends, is the hero of our story, DeepSeek OCR.
DeepSeek OCR is what's called a vision language model, or VLM. Think of it as a 2-part tag team. First, you have the deep encoder. Its job is to look at the image of the text and create a super compressed summary of it. Then it hands that summary off to the DeepSeek decoder, whose job is to read that summary and rebuild the original text word for word. So one part sees, the other part reads. Simple as that.
Okay, so the theory is fantastic. The custom-built model sounds great, but here's the billion-dollar question, right? How well does it actually work in practice? Can you really squish a document into a picture and pull the text back out without it turning into total gibberish? Well, the answer is a huge, resounding yes. Get this. The researchers found that even at a 10-to-1 compression ratio, that means using 10 times fewer tokens to represent the text as an image, the model could reconstruct it with 97% precision. I mean, that is just an absurdly high level of accuracy for such a wild idea.
And this table here really shows you the trade-offs. At that 10x compression, we're talking over 96% precision. That's nearly flawless. But look what happens when they really push it. When they get to a staggering 20x compression on longer texts, it's still pulling out the text with nearly 60% accuracy. That just shows you how incredibly robust this whole method is.
But wait, because here comes the real knockout punch: efficiency. This chart is everything. Look at a model like Miner U 2.0. It's burning through almost 7,000 vision tokens to process a page. Now look at our hero, DeepSeek OCR. It's getting top-tier results using less than 800. It is doing way more with way less. That's not just an improvement, it's a monumental leap.
So let's zoom out for a second, because this is so much bigger than just a clever way to read documents. What these researchers have stumbled upon could be a whole new foundation for how AI handles information, and maybe even how it remembers things.
The implications here are just massive. Imagine an AI that could digest entire historical archives just by looking at them, or an AI that holds on to an entire conversation's history by turning the older parts into compressed images. But the most mind-bending idea of them all is using this to give an AI a memory that works a lot more like ours.
And this is where it gets a little bit sci-fi. in the best way. The paper suggests you could use this to create a human-like memory system. So think about a conversation you just had. For the AI, that's a crystal clear, high-resolution image. It's expensive in terms of tokens, but all the details are there. As time goes on, the AI could downsize that image. It gets a little blurrier, but it uses way fewer resources. And a memory from a year ago? It becomes a tiny, heavily compressed, blurry image. The gist is still there, but the details are faded. Sound familiar? That's pretty much how our own memories work.
Which brings us to this final, really provocative thought. For years, we've thought that the ultimate goal for AI was perfect total recall, a machine that never forgets. But maybe we've been chasing the wrong thing. Maybe, to build AI that's truly intelligent, efficient, and maybe even a little more relatable, we don't just need to teach it how to remember. We also need to teach it how to forget. Maybe forgetting isn't a bug at all. It's a feature.